All right, sections 9-1 and 9-2 discuss how to find the area of different shapes. The first shape that you need to find the area of is a rectangle. Okay, the formula for the area of a rectangle is area is equal to the base times the height. So in this case, your base would be down here, and your height would be over here. Okay. Now you can also multiply the height times the base. It doesn't matter because of the commutative property. So now let's suppose that the base was equal to 10 inches. And the height is equal to, let's see, 3 inches. We can easily find the area of this rectangle by multiplying the base times the height. It's very important that you start out with the formula, and I'll be looking for this in your homework and from the problems that you're doing in class today. Okay, so start out with the formula and then just simply plug in the numbers. So we know the base is 10 and the height is 3, so we can replace the base with 10 and the height with 3. Now we just simplify and figure out what our answer is. 10 times 3 is 30. We know that our units were in inches, so our units for when we solve for area of this rectangle is in inches squared. The next shape we're going to talk about is the triangle. Here is an example of a right triangle. Okay, if we were to expand this a little bit and create two right triangles, we would have a rectangle. So really, a triangle is just a rectangle divided in two. Well, we already know what the area of a rectangle is, so we can easily find the area of a triangle if we just divide that rectangle in two. So let's suppose that the base of this rectangle was 5 inches, and the height, let's say, was 4 inches. We can easily find the area of this triangle by using the equation area is equal to 1/2 of the base times the height. If we found the area, if we multiplied the base times the height, 5 times 4, we would be finding the area of a large rectangle. But we know that the triangle is just half of that. So if we multiply the base times the height by 1/2, then we're finding the area of a triangle that has a base of 5 and the height of 4. So now, since we know that the base is 5 and the height is 4, we start with the formula and then just plug in the numbers. So we know that the base is 5 and the height is 4. Okay, so now I'm just going to simplify the right side of this equation. I like to do this first because it seems like it's probably going to be easier. So the area is equal to 1/2 of 20, which I know is 10. So my area is 10 inches squared. Again, we notice that squared sign with our units. Now here's an example of a different type of triangle. The last triangle we looked at was a right triangle. In this case, we're left with, it looks like a scalene acute triangle. That is not a right triangle, so it's not very easy to see what the height is. Okay. Now, it's going to be easy to get thrown because this looks like the height. This 3 centimeters might look like the height to you. But the height is always the perpendicular distance to the base. So if we decide that 6 is going to be our base, then the height has to be perpendicular. In other words, you'll look for that little square because it shows that it's the right angle. So it has to be perpendicular to that base. So 3 is not the height. 4 is the height. Be very, very careful about that. Now here's another hint. Most of the time, you're going to see this dotted line and a right triangle, a right sign. So it'll help if you look for the dotted line in future assessments, quizzes, problems, etc. Okay? So we solve it the same way. We start out with the formula of area is equal to 1/2 of the base times the height. And we just plug our numbers in. So we know that the height isn't 3. We know it's 4. So I'm going to plug in 6 for the base and the height of 4. And I'm just going to simplify. Area is equal to half of 6 times 4 is 24 times 1/2. Well, that has to be 12. And again, our units are in centimeters this time. And we have to have that squared sign. It's very, very important to have that. Here's an example of a parallelogram. It may not be drawn to scale, but I'm telling you right now that it is a parallelogram. Okay? Parallelograms have opposite angles that are congruent. So this angle is congruent to that angle, and this angle is congruent to this angle. And it also has opposite sides that are congruent. So this side length is congruent to that side length, and this side length is congruent to that side length. We knew that from what we talked about earlier on this year. But now let's figure out how to find the area of this shape. Okay? The area, in order to find the area of the parallelogram, you use the exact same formula as you did with the rectangle. So the area, in order to find the area of a parallelogram, you again start out with the formula. Area is equal to base times height, and then you plug the numbers in. Okay? One thing that's really tricky with a parallelogram is that this side length is not always the height. Okay? The height could be a dotted line that's perpendicular to the base. Okay? So let's suppose you were given that this side length down here was 8 feet, this side length was 6 feet, and then this one, which obviously is not a part of that parallelogram, but this one, which has perpendicular lines creating it, this side length was, let's see, 5 feet. Okay? We know that the opposite sides are congruent in a parallelogram, so we know that if this is 8 feet, this has to be 8 feet. If this is 6 feet, that has to be 6 feet, etc. Okay? Now, what's important with the parallelogram is being able to figure out which one is the base and which one's the height. Okay? And that all depends on what you're given. So here, we know that this 5 feet is the height because it's the perpendicular distance to a base. Okay? The base doesn't have to be what the figure is standing upon, because you could potentially flip this figure around. Okay, so it just depends on what you're given. We have a length that is perpendicular to a base. So we know that this 5 feet is perpendicular to that 8 feet. So I'm going to go ahead and use 8 feet as my base. Okay, so this is my base, and this is my height. So we know that 6 feet was given to us, you know, it's a little extra piece of information that your book likes to do just to throw you a little bit. So we know this, we don't need to use 6 feet, so I'm just going to cross through it. So now we just substitute our values in. So the base is 8 feet, and the height is 5 feet. Now we multiply the two values together. 8 times 5 is 40. We have, our units are in feet, so we label it as feet squared. And that's how you find the area of a parallelogram. This shape is called a trapezoid. A trapezoid has two bases. So we call them base 1 and base 2. This 1 and 2 has nothing to do with the number besides identifying it. So this is just the first base and the second base. It's the 1 and the 2 are subscripts of that number. So it doesn't mean that you multiply the base times 1 or the base times 2. It's just a way to identify that number. Okay? In order to find the area of a trapezoid, you have to find the average of the two bases and then multiply it by the height. Okay? So let's suppose that we were given this base 1 was, let's see, 12 centimeters, and this base 2 was 7 centimeters, and then we were given that the height, which is again a perpendicular distance to a base, was 6 centimeters. We can use the formula that we just talked about in order to find the area. So what we do is we start out with the area is equal to the average of the two bases, which is base 1 plus base 2, all divided by 2, because we have two terms, so we divide it by 2 in order to find the average of the two, times the height. So now we just plug our values in. Base 1 plus base 2, so that's 12 plus 7 divided by 2 times the height. So the area has to equal 19 divided by 2 times the height of 6, times 6. And I'm going to simplify early. 1, 3. So the area has to equal 19 times 3. So the area is equal to 57 centimeters squared. And that's it.